Okay, so I'm sharing my screen. Um, and where we are is class 8 was our first of 3 lessons on scales. Class 9, we did sectional, so we're not going to look at that. Class 10 was our second of 3 lessons on scales. And today is our last lesson on scales. So what I want to do is we're gonna start with a review of scales, and we're going to talk about all the different things that we learned. And then we're going to work on another scale exercising class. And then at that point, when everybody's ready, all questions have been answered, then I'll give you a scale quiz. Okay, so that's what we're doing today. So I am going to go back, and actually I am going to be on, you guys are probably going to want to open up your own screen, because what I'm going to do is open up a page where I could do a review, type a review of scales. So I'm going to open up my other laptop to our module so I could see everything that's going on. So you guys have the ability to open up a screen when I'm sharing. Is that true or no?
I think it's true. I just don't know how to do it.
Okay, so let's then start, and what we'll do is we'll flip flop back and forth. So let's look at the first sheet. So this, again, I'm at the first scales lesson, and I'm looking at our first note, our first class notes, and I'm going to open this up. It's taking a little time to open up. Oh boy, it's really taking a lot of time to open up. There it is. So what I'll do then is I'll use this screen to show you the material, and I'll start typing on the other screen that you can't see. So let me just open up a page in Canvas, and I'll call it Scale Review. And I'm going to type in there. So everybody, those of you just joined us, what we're doing is today is the third and last lessons on scales. So what we're doing is we're starting from that first lesson on scales, and we're going to work through that first lesson, which was last week, and then Monday's lesson on scales, and we're going to highlight all the important things we need to know. And while you're telling me what those important things are, I'm going to be writing them down so we have a review sheet on scales. So I'm going to start at the top. So Adam, are you here?
Yes, I'm here.
Okay, so let's talk about mechanical engineering. So ME scale, what units are they using?
Inches on both sides.
Okay, so units, right? So the units is inches, and sometimes they use decimal and sometimes fraction, but you know, ME scales are definitely going to be inches. Okay, so the units for ME are inches. And ME scale, so describe for me how I would write an ME scale, Adam.
So you'd have a fraction of an inch on the left-hand side and 1 full inch on the right-hand side.
Right. So ME scale is fraction of an inch on the left side and 1 full inch on the other side. I'm just going to have you keep going. How about if I convert it, the ME, instead of using scale, I use a size. How do I represent it?
It would be a 1 on the left-hand side, a semicolon, then some other whole number on the right-hand side.
Right. Same units on both sides. Again, what I'm typing right now, we'll review after we go all over this. Same inch units on both sides. So same units on both sides. And we'll say that it's also, it's the units equals inches. And then what about the other thing? We want to make sure that this X is a whole number, right? And there are times that we might have a size of 2 to 1, which seems like it doesn't really follow the requirement of a 1 on the left, but we have to make we have to make sure that they're whole numbers. So because X has to be a whole number, sometimes the size reverts to a whole number on the left. Sometimes it reverts to, let's just say X to 1. Okay. All right, that's ME scale. And let's go on. So Adam, Alexander, you're next. Alexander, you here?
Yeah,
Okay, Alexander. When I say a ½ inch is equal to 1 inch, so I'm still doing ME size. Sorry, I'm typing as we go along. So 1/2 inch equals 1 inch is converted to what size?
like a 1:2, so it's 1 to 2.
Correct. And does that have a verbal name as well?
Yeah, that's half size.
Right. Okay, let's do one more, Alexander. So how about if I have a 1 inch is equal to 1 inch? What is that? The same as what size?
That's 1 to 1. If
Yeah.
you said 1 inch equals 1 inch, that's what you
Correct.
get. So that's 1 to 1, and that's full size.
Right. And how about an ME scale where it's 2 inches on the left equals 1 inches on the right? What is that the same as?
It's 2 to 1, and it's double size.
2 to 1, and it's double size. How is everyone so far? Any questions? And Ben, could you monitor the chat?
Sure thing.
Okay, so that was all about ME, mechanical engineering. Scale/size. Okay, and now I'm going to civil engineering. So I'm up to Ben, you're next.
Yes.
Okay, so civil engineering scale. For civil engineering, what is the units?
We go from inches to feet.
Okay, so take a look at the column that says standard units. So civil engineers, the standard unit of measure is
Is feet.
feet, right? And then when we say the civil engineering scale, the civil engineering scale is, describe what it is on the left and the right side.
The scale is 1 inch to some amount of feet.
Right. Right, and X, what can X be?
X can be any amount of feet that starts with the numbers between 1 and 6, and anything after the first number would have to be a 0.
1, 2, 3, 4, 5, 6, and starts with, so sorry, and all other numbers that follow. So let's just use the term X leading digit must be 1 to 6, and all following numbers are 0. Is this okay that I'm writing up this review sheet for you guys? It's probably taken a lot of time because I'm typing at the same time that you guys are going through this.
I think it's going to be useful overall.
Okay.
I agree. I think it'll be good.
Okay. So, if we take a CE, how do we represent, let's go to the next person. So Berto, a CE size. So if we have a CE scale of 1 inch is equal to 200 feet, it is equal to, what would the size be?
It would
Berto,
be 1 to 200 times 12.
right? And so that's 1:2400, right?
Yeah.
Okay, great. All right. And in that case, we're really, it's also, again, it's unitless, right? No units because we have a colon, but we're really looking at inches because we converted everything to inches. Okay, do another one, Berto. How about a CE scale of 1 inch equals 60 feet? It equals to what?
So it'd be the same. It'd be 1 to 60 times 12. I don't
Right,
know if that-
720.
Yeah.
Great. Okay, so I think everyone's comfortable with this page, right? Okay, I'm gonna stop sharing for a moment. Everybody good? Thumbs up? Everybody feels comfortable with all that kind of stuff? And let me just save it. And now I'm gonna edit. Okay, so I'm gonna go back to sharing. I'm gonna close this. So what we were looking at is we were looking at this page right here. Okay, and then these are all my class notes, and let's just look through there for a moment just to see, is there anything in here that we probably didn't mention yet? Okay, oh yeah, it was just how to convert them. That's what happened. Yeah, that's all it was. It was one, well, let me see. It looks like it might be more than one sheet. Yeah. Oh, and then we did this, right? You're understanding what full size is, what half size is, what double size is, right? So, Brian, we're up to you. Can you tell me, what is the term half size means?
Half of its original size.
Half size, give me some nouns. Half size means the what? The drawing is half the size of the real object. Would you agree
Okay.
with that?
Yep.
Okay. And then double size, because remember, this adjective is only describing what you're drawing, because the real size is, the real thing is the real thing. It's the size it is. You have control about how big or small you draw it. So I'm up to Brian, right? Or is it Beto?
Me, Brian.
Brian. Okay, Brian. So describe for me in words what double size means.
Double size is double the size of the drawing compared to the original size or
Okay, say that
original
again.
object.
Say that
Double,
again.
double size is double the size of the drawing compared to the original object.
Okay, so the drawing is double the size of the real object, right?
Yep.
Right? The drawing is double the size of the real object. Okay, great. All right, let's see what else we looked at. Oh, and we know that when we represent a drawing for parts, oh, and by the way, I've graded almost everything. The only thing I didn't grade is your SOMA project, which I'm just going to have ready for when we go into the design project. So you have the front, the top, the right side view, and the ISO. You have to determine a scale to make sure that it all fits on the page. Okay. And then we talked about some examples. So the leading digit is always 1 to 6, and then all the numbers after that have to be zeros. No 7, no 8, no 9. And then we did this sheet. We took, in this case, it was written as 1/8 inch is equal to 1 foot 0 inches. So let's go to Chris. Chris, you here?
Yeah, I'm here.
Okay, so let's take a look at everything on the left side right now. Does it make sense to you that this one and this one are mechanical engineering scales?
Yes.
And tell me why.
It's a mechanical engineering scale because the measurements are in terms of inches.
Good, terms of inches. And this matches the standard, right? Where a fraction is on the left and one is on the right. But here, the one happens to be on that happens to have a 2. And then we converted them. Keep going, Chris. So 1/4 inch is equal to 1 inch. When I convert it to a size, does it become quarter size?
They can't do anything.
Yeah, it does.
Yeah, so could you explain to me how they went from 1/4 of an inch to 1 to 4?
Yeah, so what they did was they multiplied both sides by 4.
Correct.
So the fraction cancels out and it just turns to a size.
Right. And we know that whenever we use this, there has to be whole numbers. So when we used 2 to 1, we just went to 2 to 1, and this was a double size. Okay, great. Colin? Can you tell me why these two are civil engineering scales? Colin, are you here? All right, Daniel?
Yeah.
Daniel, tell me why these are civil engineering scales.
Because it's 1 inch equaling an amount of feet.
On the right side. And then are you comfortable with going from this to this, right? How did they get from 1 inch is equal to 200 to 1 to 2400? And what, wow, it's funny. I used the same exact ones. They must be in the back of my head. How did they get to the size?
They converted the feet to inches by multiplying it by 12.
Great, great. Okay, Derek, you're here?
Yep.
Okay, so this one, there are 2 here. This says 1/8 of an inch is equal to 1 foot 0 inches. And then it says 1/4 of an inch is equal to 1 foot 0 inches. Is it a mechanical engineering scale? And if not, why?
Wait, which one? Sorry, you cut out for a second.
Oh, the 1/8 inch, this top one here. Do you see my cursor?
Yep.
Okay, and then this one right here, the ones that say architecture. Why are these two not a mechanical engineering scale?
Well, because the mechanical engineering scale doesn't, it's got that 1 foot 0 inches thing on it, and the mechanical engineering scale, not only is it usually inches, but the architectural scale shows it has feet and shows the accuracy of, and shows it down to more accuracy with the inches.
Okay, so what I think you're trying to say in simpler terms, it's not the mechanical engineering scale because there would only be 1 inch on the right side. And there's 1 foot 0 inches.
Yes, exactly.
Okay,
Because
great.
most things that mechanical engineers do, like cars, any of that, you can, even if there's 100 inches, it's still
Right.
just 100 inches. It's
That's
not
right.
that big of a number.
Right. So on the right side of an equal sign for mechanical engineering, it has to be 1 inch, and this is a foot. And then why is it not, Derek, keep going. Why is it these two not civil engineering scales?
Well, because it's still, it's got the 1/8 and the 1/4 in it, the fractions of an inch, which are not usually on the civil engineering
Which are
scales.
never, right? So a civil
Yeah.
engineering scale has a 1 inch on the left, and it has a foot, no inches on the right. So these happen to be architectural scales. And the way I convert them is very similar to the mechanical, where I multiply both sides by 8, and then I have to multiply it by 12 inches because there's 1 foot here. So in order to clear the fraction, I have to multiply both sides by 8. And then, so then I take 1 foot, multiply it by 8. I have 8 feet, and I have to multiply it by 12 to get inches. Okay. And then the last sheet we worked on, we were looking at, I gave you 6 different scenarios. And I think I'm going to just have you read them for now. Each one of the scenarios tells you you want to draw something, and you first had to determine whether it was going to be a mechanical or a civil scale. So you had to write the type of scale. And then you determine what the scale would be to fit it on your drawing. Okay? And when you work with this, what's really helpful, well, for civil, we know it's going to be 1 inch is equal to so many feet. In mechanical engineering, I usually try to jump to the size, figure out what it's going to be in terms of its size. So let's go through, let me give you 5 minutes to just to read, a few minutes to read these to make sure you're comfortable with each one. Okay, Gillian,
Yes.
how did you determine whether they needed, if they were a mechanical engineering or a civil engineering scale?
I looked for whether our dimensions given were in terms of inches or feet.
Great. So the ones that I circled in red, this was given as a mechanical pencil, which is in inches. This gave dimensions of inches, and this one gave dimensions of inches. So you knew that the standard unit of standard unit for dimensions for mechanical in length is inches.
Yes.
And then the civil, the green ones were all civil because they were all dealing with feet. Good. So that's the type of scale they are. And now we were trying to figure out how to get it to fit on paper. So let's do the mechanical first. It was a mechanical pencil. Can you fit, let's go to Joel. Is Joel here? Okay, Jorge.
Yeah,
So can a mechanical pencil fit on paper? A-size paper?
yeah, I can.
Yeah, so the scale would be 1-to-1, full size, right?
Exactly.
Okay, the next number 3, it's 20 inches by 10 inches. Can this fit on an A-size paper?
No, it can't.
No, I'd have to shrink it down, right?
Exactly.
If I make it half size, then it would be 10 inches by 5 inches and I could fit that. So we used a size of 1-to-2. Good? Jorge?
Yeah.
Yeah, okay. The fourth one, there was something very tiny. It's an electronic device, very tiny. So if I drew that on paper on A size, it certainly could fit on A size, but it would be so tiny. Even if I multiplied the size by 10 and made it 10-to-1, it would still only be 2 inches by 3 inches. So we decided to make the scale 20-to-1. We made it 20 times bigger. So 20, Jorge, 20-to-1 scale, how big would this show up on my paper?
That would show up 2 inches by 3 inches.
Well, 20-to-1, not 10-to-1. I'm making it 20 times
Oh,
bigger.
4 inches. My bad.
Right. 4 inches by?
6 inches.
Right, exactly. All right. So in determining the mechanical engineering scale, you have to determine the item you want to draw on paper. Can it fit on paper, or do you have to shrink it, or do you have to make it bigger? Okay. And then for the civil engineering scale, Josh, you're here?
Yep.
Okay. So for 2, 5, and 6, which are the civil engineering scale, we had to somehow fit this on paper. Now, granted, it's 12 feet by 16 feet. There's no way to fit it on paper, right? But if we thought of it in terms of inches and we halved it, right, it would be 6 inches by 7.5 inches, and that would fit. So my scale of 1 inch is equal to 2 feet would work. Did everybody hear how I did that? I'm also thinking about whether I want to make it bigger or smaller. Well, in civil engineering, we're always making things smaller. I divided these two numbers by 2 to see if a 1-to-2 scale would work. And it would, because if I divided these numbers by 2, I would get 6 feet by 13 feet. And remember, I'm using a feet marker here. So it would turn out to be 6 by 6.5 inches. So now, Josh, How about number 5? How are you able to determine how we could fit this on paper?
So what did we come up with? So we could just do the same similar thing, just looking at in terms of inches.
Yes,
So if we look at that as 50 inches by 100 inches, it's easier to like recognize onto a piece of paper.
right.
So what we came up with was dividing each by 10. So it'd be 5 by 10 inches.
That's right. And we could fit that on a drawing, 5 by 10, right? Or, so that would be 1 inch is equal to 10 feet. Remember that we still have to put the feet here. And what if we wanted, Josh, what if we wanted it to be 5 by 10 and we thought it was too big? Because then I wouldn't have room for a title block and a border. And let's say I brought it down to 2.5 to 5, what scale would I be doing?
So then you'd be working with 1 inch equals 20 feet.
Exactly. Because in order to go from 50 feet to 2.5, I'd have to divide by 20. So it would be 1 inch is equal to 20 feet. Okay, Luis? Luis, you're here?
Yes, I'm here. I'm here. I'm
Okay.
here.
So could you talk me through how we figured out how to fit this on paper?
Yeah, so we figured out since it's an A size paper, we cannot fit 15,000 feet. And so we would have to reduce the whole amount of sizing. And so we ultimately decided on the scale to be 1 inch is equal to 2,000 feet. And if it's about to be, it's going to be, yeah, it's going to be that. It's going to be actual fractions. It's going to be like
7.5
7.5.
inches by 7.5 inches, right?
Yeah.
Okay, great. All right, let me stop sharing here. Let me stop sharing this sheet and let me come back here. Okay, so we just went over this and we just went over the class notes. And if you want further instruction on it, watch the Zoom recording. And then this homework was the sheets that we just went over. All right, so that was our first class of scales. And then our second class was yesterday. So let's go back to that. Begin second sheet of, this was just walking me through what we did. So yesterday we did a review first, and then we learned how to use an engineering scale. So let's go over that.
That's okay. Hey, can I take this moment to give you a hard time here? Yesterday, you sent me an email with a link.
Is that Sunny? Are we getting to hear about the fire station again? Let's see, is Sunny here? Let's see. Steve, I think that's you.
There's no
Okay.
noise here.
Maybe it was, I don't know. Anyway, okay.
I'm about 500 yards from you out in the mountains.
Oh, okay. Yeah, I was hearing some background noise, so. Okay, so now everybody could see the page that says using scale as a tool?
I mean, 500 yards from the class.
Yeah, not from where I am. Okay. You guys can see this? I could see Steve, Luis, George, Jorge, and Josh.
can
Can
see
you
it.
guys put your thumb up? Okay, thank you. Okay. So now, in order to use the tool, the triangular thing, you need to have the scale size of the drawing represented with a 1 on the left. So for civil engineering, no problem. We all have 1s on the left already. But in the scale for mechanical engineering, 1s are not on the left. So everybody's getting this. In order to use that scale tool, we have to have a 1 on the left. No problem with the civil engineering scale, but in the mechanical engineering scale, I have to change it to a size. In fact, even though 2 to 1 is a size, I have to have a 1 on here. So I have to change it to 1 inch is equal to 0.5 inches. Everybody see that? So I have to have a 1 on the left side always. So I have to divide both sides by 2 and I get 1 is equal to 1/2. And I'm writing it with the decimal so I know. So now, Where am I, Louise? May.
Yes, I'm here.
Okay, May.
Sorry, I was typing.
Okay, remember that the scales on the triangular scale are called 10 scale, 20 scale, 30, 40, 50, 60, right?
Yes.
Okay, so if I have a civil engineering drawing scale of this, which scale on the triangle am I going to use?
You'd use the 50, right?
That's correct. What about this one? 1 inch is equal to 4 feet. Which scale do I use on the triangle?
Would that be 10?
1 inch is equal to 40.
Oh,
40.
40. Duh. Sorry.
Right? We're always looking, the left side is always going to be a 1, and the right side is going to tell us which scale, which ruler on the triangle we're going to use. So this is a 50 scale, this is a 40 scale in May. Which
30.
scale would I use? 30. Great. Okay, Mark. So what scale would I use for this one?
Oh, this would be mechanical engineering, right?
Well,
Oh, the scale would be 1 to 4.
okay, wait, let me remember there are 3 definitions of scale. The first definition is your drawing scale. The next definition of scale is the triangular tool. And the third definition of the scale is the ruler on one side of the triangle. So would I use the 10, 20, 30, 40, 50, or 60 scale to do this?
Okay, 40.
40, thank you. Mark, next one. How about this one?
Would you do 40 again? Because there's no 80, right?
Right, that's what I wanted to hear. There is no 80 scale, so we cannot use this scale, right? What would we have to do? We'd
Use
have
a
to
20?
No, bump it up to 1 inch is equal to 10 inches. Right, so 1 inch is equal to 8 inches is not an appropriate scale. So what we would have to do is bump it up, meaning that instead of 1 inch equals to 8 inches, we would have to say 1 inch is equal to 10 inches. And in the end, we would use the 10 scale. Everybody got that? I'll
Yes.
say it one more time. 1 inch is equal to 80 inches. We cannot use that scale. Even though we would like to use it as a drawing scale, we can't, because we can't use it on the triangle. So instead of 1 inch is equal to 8 inches in real life, we would bump it up to be 1 inch is equal to 10 inches, and then we would wind up using the 10 scale. Okay, Mark, I'm still on you. What ruler on the triangular scale would I use for this one?
The 20.
Right, and what about this one?
That one tripped me up. Would that one be 10 as well?
No, okay. Remember, you guys, the left is always a 1, right? The right side tells you what scale to use. This is the 50 scale, the 40 scale, the 30 scale. Over here, it's supposed to be 1, but it's not, so we can't do it. We have to convert it. These are all 1s on the left side. So this would be the 40 scale. This would be the 80 scale if there was one. This would be the 20 scale. And Mark, what would this be?
50 scale?
Yes.
There, okay.
Yes. Awesome. And Mark, it wasn't just you who had got that wrong. Half of you would have got it wrong. Okay. So in order to use the tool, the scale that's a tool, you have to make sure the left side is a 1. And the right side tells you which scale to use on the triangle. This would be the 50 scale, the 40 scale, the 30 scale, the 40 scale, the 20 scale, the 50 scale. Okay. All right. Now we're going to take an example now. The following scale. So now we're at Rami. What is this scale called? What is this side of the triangle called? Rami, you here? Read. What is this side of the triangle called?
The 50 scale?
Correct, 50 scale. Are you sure? You sounded like you had a question mark at the end of their statement.
Sorry, the 50 scale.
Great, the 50 scale. Okay. Now we know, now if Read,
Oh.
If we're using this as a mechanical engineering scale, what units would all these guys have?
There'd be inches.
Correct. If it was a civil engineering scale, what units would all these guys be?
Feet.
Correct. Okay, now, this I think is the trickiest part. Even though it's called the, let me go to the next person. Steve, why is it called a 50 scale?
Because 1 inch, it takes 50 units to equal 1 inch, 50
Right.
divisions.
One inch on the ruler has 50 divisions, correct? So the 20 scale in 1 inch, it has 20 divisions. So it's called the 50 scale, but I would probably rather it be called the 5 scale. And the reason why is because all these numbers on here go with the 5. So even though the scale is called the 50 scale, the numbers on the scale are measurements only if the drawing scale used is 1 inch is equal to 5 feet or 1 inch is equal to 5 inches. If the scale you're using is 1 inch, so Steve, if the drawing scale you're using is 1 inch is equal to 50 feet, what should happen with all these numbers?
I guess they would just have a 0 after them.
You have to put a 0 after them. Remember, all these numbers only work if the drawing scale you're using is 1 inch is equal to 5 feet or 1 inch is equal to 5 inches. So if the drawing scale you're using is 1 inch is equal to 50 feet, all these numbers have to have a 0 on them. Sunny, I don't think Sunny's here. Sierra, you here? Sierra? Okay,
I think
Tony,
you skip me. Yeah.
no, Tony, you're next. Okay,
Then
Tony,
then you would add if it's 500, then you would add 2 zeros to all
correct.
the
You
numbers.
has 2 zeros. Great. How about the next one, which is really hard? What if the scale is 1 inch is equal to 0.5 inches? What would you do up here? Tony, I'm still on
Divide
you.
by 2.
Say it again.
Divide by 2.
Not by 2. So let's think about it. If it's 50, you put a 0,
Mm-hmm.
which really means you're moving the decimal place over 1 space. You're multiplying by 10.
Oh, so then you would move it back.
Hang on. If it's 500, you're really multiplying all these numbers by 10 twice, 100. You're moving the decimal place over 2. If the drawing scale is 0.5, then Tony, what would you do?
Then you would move the 0 point back 1 0.
Right, so tell me what all the numbers would be. 0.2,
0.4, 0.6, 8.
0.8.
8, and then 10, 12, 14.
No. Do it again. 0.2,
0.2,
0.4,
0.4,
0.6.
0.6, 0.8, 0.10.
Try it again. No. Because they're all, this is why I'm having you do this. Because
Oh, 1.
they're all gonna
That'll
be
be 1.
confused. Right.
That'll be
You're
1.
Yeah, you're just moving the decimal place 1 place over. So then this would be 1.
1.
What would this be?
1, 2.2.
1.2. This?
1.4.
Great.
1.6. 1.8. And then the 2.
Yeah. Got it? So if it's 50, you add a 0. If it's 500, you add 2 zeros. If it's 0.5, you have to move the decimal place over 1. So it'd be 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, because you're moving the decimal place over 1. Great.
There is a message in chat.
Oh,
From
could
Adam.
you read it to me?
Yes, from Adam. So if we have a scale like 1:500, could we break it up like 5 times 100?
So let's see
Then
what, okay, what, say it again. 1 inch is equal to,
1 inch, 1 to 500. Could we break it up like 5 times 100?
yeah. Yeah, you, if it's 1 to 500, so that would be 1:500, right? And that would be mechanical engineering scale. So all these are inches, and I would put 2 zeros on. What is his question? Wait, let me read the question, Adam. So if we have a scale like 1 to 500, could we break it up like 5 times 100 and then use the 50 scale because it's a factor of 5 and then multiply everything by 100? Sure. If you want, instead, yeah, so what, okay, so what I'm teaching you is if the scale is 1 inch is equal to 500 feet, I add 2 zeros to everything. But what Adam's asking is, can we just read this number and then multiply by 100? Sure. So if your scale is 1 inch is equal to 50 feet, you could read this number and then multiply by 10, definitely. So whichever one, that's a great idea, whichever one is easier. So
Yeah.
let's look at some examples.
It's because for me, yesterday when we were, no, not yesterday, on Monday when we were doing that one page from the book where it was given this scale, find that number K.
Yeah.
It was easier for me to read it off the ruler as the number was, like 7.5.
Right.
And then if we added like 100 or 1,000, I'd multiply it at the end so I didn't have to hold the zeros in my mind when reading
That's
ruler.
great. That's a great idea. Okay, so what I was teaching you initially, that if it's a if 1 inch, if you're given a drawing scale of 1 inch is equal to 50 feet, you have to add a 0 to all the things. That's how I do it. But what Adam's suggesting is don't add the 0 here. Instead, read the number, but remember you have to multiply it by 10. Same thing. I add the 2 zeros. Actually, probably the bad part about this is you're marking up the scale, right? So what he's doing is he's leaving the number here and then he remembers to multiply by 100. That's fine. Okay, so this is what we went through. So this works with all the other scales. So I'm going to close this and go back to this class on Monday and how to use a scale. And then here are the lecture notes. So let's take a look at the lecture notes. Good idea, Adam. I think that's probably easier. I just never even thought of doing that. Okay, so what did we do? Let's see. Okay, so we started out with, I gave you some examples. This we know is civil engineering because, well, actually, where are we? Jason? Jason?
Yeah,
Okay, so why is this a civil engineering scale?
because we're using feet. The
Great.
units.
Why is this one a mechanical engineering scale? Keep going.
That one, it's a, so the scale is 1 of 4, which would be 1/4 of an inch is equal to 1 inch.
Great. And what about this one?
That one, we're also using the unit of feet again, once again.
This one too.
Same with that one.
Okay, so, and this is ME, right? 1 to 8.
So
but we
that's,
can't use 1 to
inches.
8.
Mhm.
So let's go over this again, because I just talked about it again. 1 inch is equal to 8 inches. You can't choose that as a drawing scale because you can't use the tool scale. So either we have to stop down or stop up. But if you, in order to fit the drawing on paper, you need 1 inch on paper to equal 8 in the real size. You're not going to be able to fit it on the paper. It's going to slide, it's going to be off the paper. So you always have to bring the right side up in a number. Okay. And then Jason, 2 to 1 is ME2, right? But when we go to use the tool, we have to convert it and we have to make sure 1 is on the left side.
So we divide by 2.
That's right. Great. Okay, so we have 3 definitions of scale. 1 is what the drawing scale is. 2 is the tool. And 3 is the ruler. It's called 10, 20, 30 scale. So then somebody had asked me a question. Will I ever ask you a quick question like, which scale on the scale will you use to determine your drawing scale? Funny. Okay. All right. And then we went into, we drew a line that was 2 inches long and we started playing with it. I started giving you a bunch of different scales. You determined that these were all civil. And then we were able to figure out what the real length was by using the tool scale. Then for mechanical, we knew in order to use the tool, we had to have the left size 1. So we converted the scale to a size, and then we measured it off the on the ruler. Okay, let's close this.
We have a comment.
Yes, comment.
From Brian. For the 80, couldn't we use the 40 scale and then double it, or would that not work?
Brian, great idea. You can, but I've seen so many people, engineers, mess it up. So they forget to multiply or divide, and they don't know if they're supposed to multiply or divide. So I don't teach that at all. So it's better not to fudge it. The idea of these, let me stop sharing for a minute. The idea of these tools is that you're reading the number off exactly, and you're not doing any multiplication in your head. So even though you're right, if you have an 1 to 8 scale, you can use a different scale like the 40 scale and do some different multiplication, but that's not the purpose of an engineering scale. The purpose of an engineering scale is to be able to read the number right off. So it would be better to convert it to 1 inch is equal to 10 inches. But Brian, that is a real deeper level question. That was an awesome question. Okay, so let's go back to sharing screen. And so we did the lecture notes, and then let's look at the homework we had. And so we had the sheet in the book, which I have the book somewhere here, the sheet in the book, and we changed the scale. I changed them for you so they were different. And I posted the solutions. So I'm hoping that everybody is comfortable with it. And then what is this? Let's open this up. Oh, this is the table with the whale and the frog or whatever it was. So let's open this. Okay, so this is the table where we had the item on the left, and then we chose to use A size paper on all of it. And I told you what the real size was, and you had to determine whether you were going to do civil or mechanical engineering scale. And then in this case, because civil engineers tend to use the scale and mechanical engineers tend to use the size, I suggested that you use the scale for civil and the size for mechanical. So, Zane, how did you determine which one was mechanical and which was civil?
By looking if there were inches or feet or yards.
Okay, great. So how about for the airplane? What did you do?
I used civil, and then I just multiplied it by 3 to get into feet.
Okay, great. So you wound up using the civil. So any item that was in inches, you used mechanical, and anything in civil, in feet, you use civil. Now the teddy bear, somebody had asked me that question on Monday. I probably should have represented it in inches because a teddy bear is more of a mechanical design than a civil. But in any event, because I use feet, you should have used a civil engineering scale. Okay, so let me close this for a minute. So you had 2 sheets then for homework. You had this sheet to do. And let me go back to the assignment here. So you had the sheet in the workbook and you had the teddy bear whale sheet. I'm hoping that everybody finished them. And I'm also hoping that you all checked your solutions. Hang on, I'm just closing some windows. So what I would like you to do, so this is what I would like, because I think we need a break soon. It's almost 3:30. So, okay, we're going to come back now. All right, so I'm going to share my screen again, and I'm going to today's class, and this is where I wrote the scale review. So as we were doing a review, I was typing stuff. So here it is. Here's the review. So it talks about mechanical engineering scale, talks about civil engineering scale, talks about choosing type of scale, the 3 definitions of scale, how to use the scale, numbers on again, how to use the scale, and then, so basically here's a summary. Okay, so I'm going to go back here now. Okay, and what we're going to work on now is class 3, scale 3 class exercise. And this is it right here. Let me open it up. And if you want, you could print it out. I don't know if you guys like to print things out, but in the meantime, what I'm going to do is I have to stop sharing. Well, actually, let me show this first. Could somebody talk to me? I feel like I'm not talking to anybody. I don't hear anybody.
Hello, hello.
We're here.
Okay, great.
Here.
Thank you. Thank you. Okay, so we have 6 geometric pictures here, and you'll notice that there's a dimension for each picture, right? And a dimension here, and a dimension here, and a dimension here, and a dimension here. So each one has a dimension, and then each one has a scale. And then under each scale, it says size. And then it says what units you're working with and what type of scale you're using, and then which ruler scale. So first question, and I guess, Adam, we're back up to you. What is this phi represent?
Isn't that the diameter?
Right, symbol for the diameter. So those of you who don't know that yet, this phi here represents a similar symbol for a diameter. So here is the diameter. This, of course, is not a diameter because it's a circle, but it's this depth dimension right here, this dimension, and then a diameter. So the first thing is size. What I want you all to do is convert this scale to size for all 6 of them. Okay, so that's the first step. Okay, so Alexander, we're up to you. What is the size of the first one?
It's 1 to 4, or sorry. It's 1 to 48.
Hey, you know what? I think that we should first do the type. And I didn't ask you to do that.
Yeah,
So
sorry.
what is the type of scale of this?
This is architectural.
Yes, you guys, that's great that you recognize that.
And
Right.
then the size is 1 to 48.
1 to 48, right. So hang on, I'm getting my pencil lead just came out, so I have to get. Pencil. Okay, so we would convert this, we'd multiply both sides by 4, we get 1 inch is equal to 1 foot times 4 here. So 1 inch is equal to 4, it comes out to be 1 is 48. Great. Okay, Ben, what's the type of scale of the next one?
Would it be civil?
1 inch is, yeah, civil. And what is the size?
Size would be 1 inches to 48 inches.
Right, so 1 to 48.
Yes.
Can everybody see this? There, I think that's a little closer. Okay, Berto, the next one. What's the type here?
Would it be ME?
Yep. And what's the size?
The size would also be 1 to 4, right?
Yeah. Yeah, so actually, what is the scale? What they
So
gave
the-
you is actually the size. What is the scale?
So the scale should be 1 equals 4.
1 inch is equal to 4, but on a mechanical engineering scale, it's usually fractional on the left, right?
Yeah, so could we do 1/4 is equal to 1?
Yep. 1/4 is equal to 1. Great. Okay, Brian, this one. What kind of scale is it?
Mechanical as well.
Right. And they actually have it written as the size already, right?
Yep.
So if we wanted to write it as a scale, what can we write it as?
1. Dang it. 1 inch equals 4 feet, I think. Or no, right?
Inches. No, it's just 4 inches is equal to 1 inch.
Almost.
It's usually on the left, it's a fractional, but it winds up it's a whole number because they're making it bigger. Okay, and then Chris, what type of scale is this?
This is a civil engineering scale.
Great, and what's the size?
The size would be 1 inch to 480 feet.
Yeah.
Right.
Not feet though, right? You've just converted it to inches.
Oh, so it's 1 inch to 480 inches?
Yeah, right.
Yeah, all right.
Right. Okay, great. Okay, and shoot, that was Brian, right? So Chris,
Yeah.
what's the next one? Wait, Chris, you were the one who just answered, right?
Yeah, I just answered.
Sorry. Okay,
That's fine.
Colin. Daniel.
Yeah.
Okay, what's the type of scale?
That's mechanical, right?
Yep. And what's the size?
Would it be 1/40? Wait. Oh shoot.
Instead of having an equal sign, what does the size have?
The colon.
Colon.
So
And
is it just 1/40?
yep, it has the same inches on the left, the same inches on both.
Okay, yeah.
Okay. All right, so now let's go through them. And now that we know the type of scale, and actually let's just forget the architectural one because we're not going to do that one. Okay, so with these 5, what I want you to do now is what units are you looking at? You're looking at a civil engineering scale. What are the units? ME, what are the units? Mechanical, what are the units? CE, what are the units? ME, what are the units? And then which side of the ruler would you use? Would you use the 10 scale, the 20 scale, the 30 scale, the 40 scale, the 50 scale, the 60 scale? Which scale? These are the ruler question. Okay, so fill in the units and the ruler for each one of these. Derek, we're up to you. So for this one right
right.
here, what's the units?
One sec, I'm not in speaker view for some reason.
Say it again. Oh,
It just went out of speaker view. so-
okay.
Okay, there we go.
Civil engineering scale. So what units are we working with?
We're working with feet.
Great. Do the next one too. How about mechanical?
Inches.
Right. Okay, Gillian. How about the next 3? Mechanical, what units?
Inches.
Yep.
And then the next one, we're in feet.
And the last one?
And inches again.
That's right. So that means when we actually do measure, we know that this first one, the thing that we measure is going to be in feet. And the second one, we know it's going to be in inches. The third one, we know it's going to be in inches. The fourth one, we know it's going to be in the feet. And the fifth one, we're going to know it's in inches. Okay. Okay, Joel. Okay, Jorge.
Yeah.
Okay, remember, with civil engineering scale, we look at the scale. And here's civil engineering, we look at the scale. And mechanical engineering, we look at the size, and the size to determine which ruler we're going to use on the triangular scale. Because it's important that we have to have a 1 on the left side. All these have a 1 on the left side. But Jorge, what about this guy? Does it have a 1 on the left side?
No, it doesn't. Would we divide by 4?
Right, so we would get 1 colon 0.25, right? Is
Yeah,
that
exactly.
okay? So now let's do these first. So Jorge, what ruler would I use to measure this?
The 40?
Yep, the 40 scale. How about this one?
Same thing.
40 scale. Skip that one. How about this one?
Same thing.
Right.
40 scale.
And the last one?
40 scale.
Look at that. They're all the 40 scale. Should I use the 40 scale for this?
No.
Jorge?
Probably not.
No, why not? How did you know that you were using the 40 scale for all of these?
Because they all have a 4 in it.
You got to be more specific. It's not just that there's a 4 in it. Where is the 4 positioned?
At an inch.
No, here. So 1 always is on the left, right? And whatever
Yeah.
is on the right is the one that determines which ruler scale we use, right?
Yeah.
Right? The one on the right. Well, here, the one on the right is 25. Can we even use a scale for this one?
No.
How come?
Because there's a 5.
Right, it's got to be 10, 20, 30, 40, 50, or 60. So this was not a good scale to choose. What scale? Jorge, I'm still putting you on the spot. What scale or size would have been more appropriate to do for this so that I could use a scale?
I'm not sure, to be honest.
Okay, so let's try. The 4-to-1 doesn't work. So either I could use a 3-to-1 or a 5-to-1, right? You
Yeah.
agree? 1 up or 1 down. Well, this one is going to turn out to be 1 inch is equal to 1/3 inches, which is 0.33333, right?
Yeah.
Which is no good because it's not a 10, 20, 30, 40, or 50. This one turned out to be 1 inch is equal to 0.5 inches, 0.4 inches, which turned out to be 0.25, which is no good either. But what about this, the 5-to-1? What does that turn out to be? 1 inch is equal to?
0.20. So that would be a good one to use.
Yeah, and then what scale could we use?
The 2 scale or
The 20
scale.
scale.
Sorry.
Great. Good. Okay, so what we're going to do is we're going to cross this out. And instead, we're going to say the scale is 5-to-1. And we know the size is going to be 5-to-1. This is really the scale is 5 inches equal 1 inch. The size is 5-to-1. And then we're going to convert this to 1 to 0.2. And now, based on these scales, I want you to figure out what this dimension is. What is its dimension? So here, it's a civil engineering scale. You're using the 40 scale. It's 1 inch is equal to 40 feet, 4 feet. What is this distance? So let's do the first one first. And I have to run in and get a scale. I'll be right back. So it's based on its diameter. Okay, Josh, what did you get? What did you get as the diameter, Josh? Luis?
Yes, I'm here.
What'd you get?
I'm still uncertain, but I said it's 2 feet.
Well, we learned, let me zoom in. We learned that we're looking at a scale of 1 inch is equal to 4 feet, right? We know the units are going to be in feet, and I'm using the 40 scale. So I'm flipping to the 40, right? And I'm measuring the
yes.
diameter. And when I measure the diameter, I have 8. I got 8. So the diameter was 8 feet. Luis, everybody
Okay,
try it again.
perfect.
Make sure you get 8 feet.
Perfect.
Okay.
Hey, Joanne.
I'm not getting that.
I got 7 feet.
I got 7 as well.
Did everybody print out it? We probably all printed out something different, huh?
Oh, yeah.
Right? So we're gonna all be a little bit off depending on how we printed it out on a piece of paper. So Gillian, what did you get?
I got 67 feet.
67?
Yeah.
Okay, well, there's no way it's 67 feet because this is 1 inch is equal to 4 feet. So when I look at this scale, I know all these numbers. Well,
Oh,
how
the
many
6 thingy. Right, you don't add the 0. Okay.
Right, so did you get 6.7 feet?
Yes.
Okay, 6.7. And somebody got a 7 something?
Yeah, I got exactly 7 feet.
Okay, so it's really gonna depend on how it's printed out. But you could see how mine's an 8, right? You guys?
Yep.
Yes.
Okay. All right, so we're all gonna be off a little bit. All right, Luis, I'm gonna have you do the next one. Now the scale is 1 inch is equal to 4 inches. And you need to measure it again with the 4 scale. What did you get, Luis?
I'm still trying to figure this out. Sorry about that.
No, that's okay. So what you're doing is you got to use the 4 scale, right?
Yes, yes.
Okay. So because the size, it's mechanical engineering, the size is 1 to 4. The 4 tells you have to use the 4 scale. And so I took out the 4 and I'm measuring it. And to me, it came out to be 8 inches, but to you guys, it probably came out to be 7, 6.7 or 7 or something.
Hey, Joanne.
Yeah, Adam.
And for the ones that have a circle in them, we have to make sure to measure along the center lines, right? Where they have the little dashes in the middle.
Well, for this one, you were trying to find the diameter, right?
Mm-hmm.
So yes, you were measuring it right along the center.
Okay.
In this case, the dimension goes from this point to this point. So you can go and measure over here, but usually it's better to measure where the extension lines are.
Okay, got it.
Okay. Luis, do you have a scale on you? That's the question.
Yes, I do. The only problem is the constraint of the sizing for the people because I haven't been able to print it out.
Oh,
So
you're
I'm actually using a
paper.
display, and it's just extremely more difficult.
Okay, so yeah, I mean, you could go up to the screen and try to measure, but yeah, I would suggest.
Yeah, it's just a little difficult to actually get the size constraints to
Yeah, what I'll
measure
do
up.
is I'll let you guys take a photo of this at the end and then print it out for yourself. Okay. All
Okay,
right, so
perfect.
the next one, May.
Yeah, I measured 7 as well.
Okay, for this one as well?
Yes.
So in this case, we're looking at a scale of 1. Which scale did you use?
Oh, I used the wrong scale.
Okay, so which scale should it be?
The 50 scale. So I got 9.
No. The number on the left has to be the 1, and the number on the right is what tells you what scale it is.
Oh.
So which scale are you using?
Okay, sorry. These are confusing me for some
That's
reason.
okay. Which scale are you using now?
The 20.
Right. So you guys, whatever, there's always a 1 on the left. And whatever is on the right is what determines which ruler scale you use. Okay, the number on the right. So if this is 1 is to 0.2, you got to use the 20 scale. And then you have to move a decimal place over. So May, do you want to do it? What did you get?
Yeah, so I got 3.5 as I'm measuring now.
Well, you measured 3.5 off of here, right?
Yes.
But remember the scale, it's 0.2. So if you're using these numbers, that's based on 2. If it's 0.2, you have to put a decimal in front of everything.
So it's 0.35.
Right.
When you
And mine-
convert it,
and
yeah.
Mine came out to 0.4. Okay, Mark, you're next. What ruler scale are you using?
A 40.
Mark? Okay, Rami?
Yeah.
What ruler scale are you using? For this one?
40.
The 40 scale, right? And it says 1 inch is equal to 40, right? So what do you have to do with the 4 on here? What do you have to do with all these numbers?
I'm not too sure on that, to be honest.
Okay, so 1 inch is equal to 40 feet. All the numbers on here have to do with the 4. So if it's 40, you have to add a 0 to everything.
60.6.
Right, and I got 80 feet.
Why did I should get 80 feet?
Okay, who is that asking?
Sorry, I was wondering how you got 80 feet because I got
Is that Tony?
yeah.
Okay, so remember my printout is different than yours, right? What did you get?
Close to 7, but it's 70, but it's a 60.8 for me.
What? Say it again?
60.8.
Okay, it's not 60.8, it's probably 68.
Oh, 6.
Right, because if you add a 0 to everything,
Oh, got it. Yeah.
right?
Yeah, 68.
Okay. And maybe what Adam suggested is read the number 6.7 and then multiply it by 10. And then it's 67 and you won't mess up with the decimals,
Got it. Thank you.
right? Okay. All right, so we got 80 and then read. How about this last one? What scale am I using?
The 40 scale.
40 scale. And when I go to measure the diameter, and it's a 40 scale, so what's the measurement? What's the real size?
I got 7 inches. Or it'd
It
be
is-
70 inches.
That's right, 70 inches. I got 80, but. All right, so what I'm gonna do now is,
Yeah.
okay, you guys, I'm gonna have you take a photo of, wait, let me get it in focus.
Yes, mom. Yeah, no, it's not.
Okay,
Hey,
take
Jorge,
a,
you're unmuted.
I got it. Take a photo of this, you guys. Okay, I want to go over this all. So 1, you were able to determine the type of scale it was, whether it was in feet or inch. Civil, mechanical, mechanical, civil, mechanical. Then given, they either gave you the scale or they gave you the size and we converted it to scale and size. And I don't think you have problems with that. Also, I don't think you had problems with the units, because if they gave it to you in feet, you knew you were going to measure in feet. If they gave it to you in inches, you knew you were going to measure in inches. The last thing then, the second to last thing was, in terms of what ruler, what side of the ruler do you use? You always look at after the equal sign or after the colon, and that is the number. This has to have a 1 on the left, and whatever number is on the right determines what kind of scale you're using. It happened to be the 40 scale, the 40 scale, the 40 scale, and the 40 scale. And it was based on 4 feet, 4 inches, 40 inches, 4 feet, 40 feet. And then you use the scale. And so everyone, if I had a scale of 1 inch is equal to 4 feet or 1 inch is equal to 4 inches, I read the number right off of here. But if they have something where it's 1 inch is equal to 40 feet or 1 to 40, you have to add a 0 to everything on here. Okay. Or what Adam said is, if the whole number is just the number, then you just read the number. But if the whole number here is 40 or 400 or 4,000, you have to remember to read the number and multiply it by 10 or 100 or 1,000. Okay, I'm gonna go back to the screen. Okay, I felt like there was a little confusion in what we were just looking at. What questions do you have?
Looking at the bottom left-hand corner, the confusing one where it was the scale was 4 to 1. You just decided to switch it in decimal. Is that what we just need to do? Like, when do we know we need to switch to decimal?
Okay, hang on. Okay, so in this bottom one here, they told me that the scale was 4 to 1. Well, I knew it was metric. I knew it was inches. And they actually wrote it as a size. So the scale is really 4 inches equals 1 inch. Everybody good so far, right? They
Yes.
gave it to me as-
Yeah.
Okay. So then the next thing is, in order to be able to determine what ruler I use, I have to have a 1 on the left side. Okay. So let me just rewrite it here. They gave me 4 to 1. Well, I have to get a 1 on the left side. And in order to get a 1 on the left side, I have to divide both by 4. And this comes out to be 4 1/4, which is equal to 0.25. There is no scale that is 25. There's a 20 scale, there's a 30 scale, there's a 5 scale, but there's not a 25 scale. So I realized that this was not going to work. So I either have to go up or I have to come down. And if I go to 3 to 1, I wind up on the left side. If I have 1, I get a third on the right side, which is 0.3333. So again, this is not going to work. I have to have just a whole number with zeros. So then I said, okay, well, let me try 5 to 1. And 5 to 1 is 1 colon 1/5, and 1/5 is 0.2. And there I got it. I could use the 20 scale and make sure that I move the decimal place over 1. Gillian, does that help? Is that better?
Yeah, that makes more sense. We had the we have like the fraction. I was just like, I got confused because I was looking at the fraction to be able to tell which scale we used and looking for like the 1/5, but obviously that doesn't work. We have to look at it in a decimal form.
That's right. We have to convert it to a decimal form.
Okay.
Okay. Because 1/3, there is no 1/3. There is no, 1/4 on here. There are only 4, 5, 6. Got it?
Yes.
Okay. Okay, what other questions do you have?
For the very first one, the architectural one that we crossed out, would it have just been the size of 1 to 4 units feet and 40 scale as well?
Okay, so let's, in this case, yeah, we could just do it. So it's 1 to the, yeah, it would be 1 to 4. The units are gonna be in feet. The ruler would be the 40 scale. And yep, we could just measure it because it's 1 to 4. It winds up, even though it's an architectural scale, it turns out to be a good architectural scale that we can actually use on an engineering scale. You're right. Good job, Adam.
Thank you.
And then I have a question.
Yeah, Reed.
So for the size, it says like 1 to 48. Oh, never mind. I got it.
Yeah, so the size is
just-
1 to 48, but
yeah.
that does not help me on
Exactly.
using my ruler. I have to use this one. So for the civil engineering, let me just write it up here. I'm kind of making this really messy now. For the civil engineering scale, I really need to look at the scale because it's 1 inch is equal to X feet. For the ME scale, I need to look at the size because that's where it says 1 to X. In order to figure out which ruler to use, I have to have a 1 on the left side and some value on the right side. So for civil engineering, I'm going to look at the scale, but for ME, I'm going to look at the size.
Thank you.
Okay, great. Okay, what other
Well,
questions?
I have a question. For some reason, I'm getting confused between what scale to use for double versus half size.
Sure. So, so we know that double size means my drawing is 2 times the size of the real. Do you agree?
Mm-hmm.
And half size, the drawing is half the size of the real, right?
Yes.
So double size is 2 to 1. Because the left side talks about the drawing and the right side is the real. And half size would be 1 to 2, or 1/2 inch is equal to 1 inch. So the left side represents what the drawing is, and this is the real. So if the real is 1 inch, the drawing is 2 inches, you know it's double size.
So for that double size, you would use the 50 scale, and for the half, you would use the 220 scale?
Correct. So in
Oh, okay.
order to find out which tool scale to use, remember the rule is I have to have a 1 on the left side. So I have to convert this. 1 is here. So divide both by a half and I get a half, which is the same as 1 is to 0.5. So I would use the 50 scale. Tony, how's that? Okay?
Yes. Thank you
Okay,
so
great.
much.
Okay, what other questions? Okay.